Hi you two, welcome to your math lesson for today. So we're going to carry on with our fluency, looking at bridging 10 or that make 10 strategy. So what we've got is 8 plus 4, so I've got two addends that are going to make a number larger than 10. So I've got 8 and I'm starting with that on my tens frame. Now I'm going to add 4, but instead of adding 4 all in one go, I'm going to add it in two parts. Now, the first thing I'm going to do is partition this into a number that will bond with my 8 to make 10. So as you can see from my tens frame, I have got 2 squares missing to make my whole 10. So that means I need to add 2 more. There we go, I've got 2 more, and that will make my whole 10. So I'm going to write that here, 2. But I didn't want to just add 2. I wanted to add 4. So how many more do I need to add? Well, I've already got 2, 3, 4. I needed to add 2 more to be able to add my whole 4 in total. So what I did is I did 8 plus 2 because I know that equals 10, and then I added 2 more, and 10 plus 2 equals 12. Why don't you have a go at pausing the video and seeing if you can work out the answers, and when you're ready, play the video and we'll go through it together. Well done everybody for having a go at that. Let's go through the answers then. So I have got 9 to start with, so I've got 9 counters on my tens frame. I'm going to add 5. I'm not going to add 5 all in one go. I'm going to partition it. That means break it down into smaller chunks. So first of all, I'm going to break it down into a number that will bond with my 9 to make 10. And if I have a look at my tens frame, I can see that I've got 1 space left to make 10. So that means I've got to add 1. But I didn't want to just add 1. I did that because it got me to 10, and 10 is a nice, easy number to work with. I want to add 5 in total. So how many more do I need to add? Well, I've got to add 4 more. And you can see now that I've got 5 blue dots all together. But instead of adding that 5 all in one go, I added my 1 to make 10, and then 10 plus 4 equals 14. Super well done. Okay, let's have a look at this one then. 6 plus 5. So I'm starting with 6. I've got 6 counters on my tens frame, and I'm going to add 5. I'm not going to add 5 all in one go. I am going to partition my 5 into 2 smaller numbers. Now, the first number that I'm going to partition it into is going to bond with my 6 to make 10. Now, hopefully you should know your number bonds to 10, but if not, I can see over here on my tens frame that I've got 4 spaces left to make it full. So that would mean that I first need to partition it into 4. But I don't want to just do 6 add 4. I wanted to add 5. So I need to add 1 more. To add 1 more to make my whole 5. So I'm still adding 5 counters. You can see that here, 1, 2, 3, 4, 5. I'm still adding those 5 counters. I'm just adding them in 2 steps. So I'm doing 6, add 4, add 1. Because I know that 6 add 4 equals 10, and then 10 add 1 equals 11. Okay, 8 plus 6. I'm starting with 8 counters on my tens frame. I'm going to add 6, but I'm going to partition my 6 and add it into 2 smaller parts. So what do I need to do first? Well, I need to partition it into something that is going to bond with my 8 to make 10. And you can see here that I've got 2 spaces left to fill my tens frame. So that is going to mean that this number here is 2. So 8 plus 2 equals 10. But I didn't want to just do 8 plus 2. I wanted to do 8 plus 6. So how many more blue counters do I need to add to make sure that there are 6 blue counters being added in total? Well, 2, 3, 4, 5, 6. So I had to add 4 more counters there. So 8 add 2 equals 10, and 10 add 4 equals 14. Well done if you got those right. Okay then, so moving on with our shape learning. Today we're going to have a look at 3D shapes. So I just want you to have a think. What is a 3D shape? What makes it different from a 2D shape that we've learned about? Pause the video, have a think, and when you're ready, play it and check if you were right. Lovely, let's have a look then. So a 3D shape is a shape that you can pick up. And 3D shapes have edges, vertices, and faces. So you can pick them up because they have got height, they've got width, and they've got depth as well. And I've got some here as an example, so you can physically pick it up and look at all the different sides of it. Now, they've got faces. Now, a face is this part here. It's got edges and it's got vertices. So have a look at this selection of shapes and pause the video, and I want you to point to all the shapes that are 3D. Have you had a go? Well done. So all of these are on paper, so it's very, very tricky to see, but you will notice that 3D shapes have got extra lines drawn on them to try and show either that depth or that width or that height. So you can see here that this is not just a flat shape. This is a flat shape, so this is 2D. This is just a flat shape, it's 2D. You can see here that this has got some extra lines drawn in it to try and help it look like it's standing out. So this is a 3D shape. This is a 3D shape. You can tell from that line around the middle, it's showing you that it's not just a circle, but it's actually going all the way around like a ball. So this is a 3D shape. This is a 3D shape. This is a 2D shape. This is our pentagon. This is a 2D shape. And this is a 3D shape. So well done if you spotted all of those. So let's have a little bit of a closer look at our key vocabulary for today's lesson. We've got faces, edges, and vertices. Now we've already looked at the word vertices on our 2D shape, so hopefully this should be quite familiar. So let's have a look then at our definition. So 3D shapes have height, this way, width, this way, and depth, which is this way. So that's what makes them 3D. Our 2D shapes have just got height and width. They just have those 2 dimensions. But a 3D shape also has that depth to it as well. So faces are flat or curved sides on 3D shapes. Let's say that together. Faces are flat or curved sides on a 3D shape. So if you have a look at this one, this is an example of a flat face there. This is a side to my 3D shape and it is flat. Or you might say that this is a face, but this is not flat, this is curved. And you can see from my finger rolling around it, it is a curved face. Edges then. Edges are where 2 or more faces meet. Let's say that together. Edges are where 2 or more faces meet. So you can see here, this is a face and this is a face, and they've joined together to create an edge. There you go. So an edge is almost like a line that you can run your finger across. Now again, they could be straight or they could be curved, like you can see on this one. So this is a face and this is a face, and they meet at an edge. Vertices are points usually where edges meet. Let's say that together. Vertices are points where edges meet. Sorry, let's say that one more time so that I can say it properly. Vertices are points usually where edges meet. Super. So you can see that this is an edge, this is an edge, this is an edge, and they are meeting at this point here, which we call a vertex. If I've got more than one vertex, I call them vertices. Now it says usually where edges meet, because on this 3D shape here that we've got, there are no edges here, but this is still a vertex. It's still a point, okay? Lovely. So what we're going to do is we're going to run through some 3D shapes. We're going to talk about the names of them, and we're going to talk about their properties. Now, their properties means what it has. Their faces, their edges, and their vertices. And to support you in that, we've got our success criteria here, reminding you of our key vocabulary and what they mean. And we've also got a word mat over here to help you remember the names of those 3D shapes. So this one here, this is our, can you find a shape that looks like it on our word mat? Well done if you spotted it. This is our cube. And a cube has, well, let's count the faces. What I'll do is I'll do it on here first, and then I'll do it on here. So a cube has got how many faces? 1, 2, 3, 4, 5, 6 faces. So a cube has got 6 faces. Let's see if we can spot those on the drawing. It's a little bit tricky to tell, but we'll do our best. So we've got this face on the top. We've got this face at the back. You can see that one there at the back. So that's 2. We've got this face here on the side, which is 3. We've got this face on this side, which is 4. We've got this face here on the bottom, which is 5. And then we've also got this face here on the front, which is 6. Okay, let's have a look at, let's have a look at edges. Let me just move that one. So let's have a look at edges. So edges are where the faces meet, and they are usually lines. They can be straight lines or curved lines that you can see. So a cube has got, I'll show you the front of it first. 1, 2, 3, 4. And then on the back, it's the same, 5, 6, 7, 8. And then we've got 9, 10, 11, 12. So a cube has got 12 edges. Let's see if we can find them on our drawing. So we've got 1, 2, 3, 4 on the top. 1, 2, 3, 4 on the bottom. So 4 and 4 is 8, 9, 10, 11, 12. There we go. And let's count those vertices. Remember, a vertex is where those edges meet to create a point. So I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. And let's see if we can find them on our drawing. We've got 1, 2, 3, 4, 5, 6, 7, 8. Well done if you spotted all of those. Right, let's say our sentence frame together then. A cube has 6 faces, 12 edges, and 8 vertices. Okay, let's move on to this shape then. Can you find what this shape is called from the word map? Well done if you said it is a cuboid. So a cuboid has, this is my cuboid here. A cuboid has, let's have a look then. Count the faces first. 1, 2, 3, 4, 5, 6. 6 faces. Let's see if we can show that on our shape, on our drawing. So we've got 1 face at the back. 2, we look at the one on the top. 3, look at the one on the side. 4, look at the one on this side. 5, looking at the one on the bottom. And then we've got this one on the front to do here, which makes 6. Okay, let's count those edges. And remember, edges are where the faces meet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's got 12 edges. And we can see that on our shape here as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And let's count those vertices. 1, 2, 3, 4, 5, 6, 7, 8. And let's have a look at identifying those on our shape, on our drawing. 1, 2, 3, 4, 5, 6, 7, 8. Lovely. Let's say our STEM sentence together. A cuboid has 6 faces, 12 edges, and 8 vertices. Now that sounds very familiar to me. I'm sure this had the same number of faces, the same number of edges, and the same number of vertices. So my question to you is, what's the same and what's different between our cube and our cuboid? Pause the video and have a go. Well done if you've shared some of your ideas. So what I'd like to draw out to you is that a cuboid and a cube have the same number of faces, the same number of vertices, and the same number of edges. You can see that here as well. So the only thing that makes them different is the shape of their faces. Now you can see that a cube, whichever way round I turn it, it looks the same. And that's because all of these faces are the same. They are all squares. They're all the same size. They've got the same sized edges. Whereas our cuboid looks different depending on which way I turn it. And that's because some of the faces on a cuboid are rectangular. So that's what makes a cube and a cuboid different. Now, because rectangles can be different shapes and sizes, cuboids can look different, whereas all cubes will look the same. Some will be big, some will be small, but they will all look the same. Whereas cuboids can look different because rectangles can be done in various ways. Okay, let's have a look at this one then. Can you identify the shape on the word map? Well done if you said that it is a sphere. Okay, so a sphere has, just go grab my sphere. It's the best one I can find. Unfortunately, it's quite holy, but it is essentially a round ball. So a sphere has, well, it's just got this one continuous curved face. So it has got one face that goes all the way around. And because it's only got one face, it can't meet any other faces, so it's got no edges at all. It's got 0 edges. And if it's got 0 edges, those edges can't meet to create a vertex. So it's also got no vertices as well. There we go. Super. So let's say our STEM sentence together. A sphere has 1 face, 0 edges and 0 vertices. Well done, year 2. Right, next one. Can you identify the name of the shape from the word map? Well done. If you said that it is a cone. Fantastic. So a cone has got, now let's have a look. This is my cone. So a cone has got, well, it's got a flat face on the bottom, and it's got this curved face around the sides and top. So it's got 1, 2 faces. It's got 2 faces, and you can see that being shown here. You can see that it's got the flat face on the bottom, and you can see this curved face going around it there. Okay, let's count those edges. So remember, edges are where the faces meet, usually making a straight or a curved line that you can run your finger across. So this is a face and this is a face, and they meet to create this edge. This is the only edge that the cone has. So it's got 1 edge. And how many points are there on the cone? It's just got 1 point at the top. So it's got 1 vertex. So that means we need to change this to vertex, because if we've just got 1 of them, then it can't be plural. So let's say our sentence frame together. A cone has 2 faces, 1 edge and 1 vertex. Well done, year 2. Okay, let's have a look at the shape then. Can you identify it from the word map? Well done if you said that it is a cylinder. So a cylinder looks like this. There you go, you can see a cylinder. Maybe like a tin or a tube of toilet roll. So a cylinder has got, well, it's got 1 face, 2 faces, 3 faces. So it's got 1 on this side, 1 on this side, and 1 curved face that goes all the way around the middle. So that makes 3 faces in total. And those faces join up here to create 1 edge, and here to create a second edge. So it's got 2 edges. But those edges never ever meet. So this shape has got 0 vertices. Well done. Let's say our STEM sentence together. A cylinder has 3 faces, 2 edges, and 0 vertices. Oh, shapes are getting trickier now. Can you identify the shape from our word map? Well done if you said that it is a square-based pyramid. And you say that one, it's quite a long one. Square-based pyramid. Lovely. So a square-based pyramid has, let me show you my square-based pyramid. So a pyramid is basically any shape that has a base, which is the bottom of the shape. Now, the shape of this base is a square. So that's why it's called a square-based pyramid. And when I stand it on its base, all of the sides are triangles. So that's what defines a pyramid. So it's got triangle bases leading up from the base to meet at a point or a vertex. So we can see that a square-based pyramid has got 1 face on the bottom, which is its square base, but then 4 triangular faces coming up off that. So it's got 5 faces all together. And hopefully you can see that from the picture. Let's have a look. We've got the triangular face at the back. We've got the triangular face on this side, the triangular face on this side. We've got the triangular face at the front here. And then not forgetting the base of our pyramid here. That makes 5 faces. Okay, so let's count those edges. If I've got a square on the bottom, I've got 1, 2, 3, 4 edges going along the bottom, and then 5, 6, 7, 8 edges in total. And then the vertices. So these edges join to make 1, 2, 3, 4, 5 vertices. Well done. Let's say our sentence frame together. A square-based pyramid has 5 faces, 8 edges, and 5 vertices. Okay, let's have a look at this one then. What shape is this? Can you identify it from the word map? Well done if you said that it is a triangular base pyramid. Let's have a look at our triangular base pyramid. Well, you can see that it's a pyramid because it's got triangular faces going up on the sides. And if I turn it over to look at the bottom, you can see that the base of my pyramid is a triangle shape. So the base is a triangle shape, so it's a triangular based pyramid. Let's count the faces then. It's got 1 triangle face on the bottom, 2, 3, 4. There we go, so it's got 4 faces. Count those edges then. 1, 2, 3, 4, 5, 6. It's got 6 edges. And let's count those vertices. 1, 2, 3, 4. 4 vertices. So hopefully you can see on here, it's got 1 face here, 2 faces here, 3 faces, 4 faces. You can see that it's got 1, 2, 3, 4, 5, 6 edges, and hopefully you can see it's got 1, 2, 3, 4 vertices. Let's say our STEM sentence together. Our triangular based pyramid has 4 faces, 6 edges, and 4 vertices. Okay, I believe this is our last shape. And this one, can you find it on the word map? Well done if you said that it is a triangular prism. That's quite a nice one to say. Why don't we have a go at saying that? Triangular prism. Well done. So a triangular prism then. Now a prism is any shape that has kind of a 2D shape on its front, and then it is being stretched backwards with these rectangular bases. For example, this here is a hexagon. And if I stretch my hexagon back, you can see that on the opposite sides, there are 2 hexagons, but in the middle, joining up all those edges are these rectangular faces. So you can see that pyramids have got triangular faces meeting at a point, whereas prisms have rectangular faces that almost make it look like our 2D shape is being stretched backwards. So this would be a hexagonal prism, whereas this would be a triangular prism because it's got triangle faces on opposite sides, and they're being joined together with these rectangular faces. So let's count how many faces it has all together. Well, it's got 1, 2 triangular faces, and it's got 1, 2, 3 rectangular faces joining them together. So it's got 5 faces all together, and hopefully you can see that here we've got 1, 2, 3, 4, and 5. There we go. Right, let's count those edges then. 1, 2, 3. Same on this side. 4, 5, 6, 7, 8, 9. Got 9 edges all together. Hopefully you can see that from the drawing. Let's have a look. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And the vertices then, it's got 1, 2, 3, 4, 5, 6. It's got 6 vertices, and hopefully you can find those on the drawing as well. Let's have a look. 1, 2, 3, 4, 5, 6. So let's say our STEM sentence together. A triangular prism has 5 faces, 9 edges, and 6 vertices. Well done. Okay, so now we're going to play a little game of riddles. And what I'm going to do is I'm going to read out a description of a shape, and you need to have a look at our word mat to try and work out which shape am I describing. You ready? Look at this first one. I have 0 vertices, 3 faces, and 2 edges. What am I? So I think the easiest way to identify this shape would be to have a look at this clue here, 0 vertices. Now we didn't have many shapes that didn't have any vertices at all, and the vertices are quite easy to identify because they meet at a sharp point. So let's have a look. Does this shape have vertices? Yes, it's not this one. Does this shape have vertices? Yes, it's not this one. Does this shape have vertices? Yes, it's got 1 vertex, so it's not this one. Does this shape have any vertices? No, so it could be this one. Does this shape have any vertices? Yes, it's not that one. Does this shape have any vertices? This one here? Yes, it's not that one. Does this shape have any vertices? No, so it could be this one. Does this shape have any vertices? Yes, it does, so it's not this one. So look at that, we've already narrowed it down just to these 2. Now, if you have a look at the other properties, we want a shape that's got 3 faces. Now, we know that a sphere has got 1 face that goes all the way around, so it can't be the sphere. So let's have a look at our cylinder. Let's count the faces on the cylinder. 1, 2, 3. So it is our cylinder. Does it have 2 edges? 1, 2. Yes, it does. So it is a cylinder. Well done if you got that one right. So I'm going to read you the next one, and then you can pause the video and have a go at working it out yourself. I have 5 vertices, 5 faces, and 8 edges. What am I? Okay, well done if you had a go at that. So let's have a look. So our cube, let's just choose the faces first. I think the faces is often one of the lowest numbers. So let's have a look at those faces. So how many faces does a cube have? And the cube has got 1, 2, 3, 4, 5, 6 faces. So it's not the cube. And I know that the cube and the cuboid have the same number of faces, edges, and vertices. So by that point, it's also not a cuboid. The cone, I know, just has one face on the bottom and one curved face around the side. So that's not that one. We've just calculated that the cylinder has got 3 faces, so it's not this one. The square-based pyramid has got the square base on the bottom, and then 1, 2, 3, 4 triangles around the side, which altogether is 5 faces. So it could be this one, the triangular-based pyramid. It has got the 1 face on the bottom, 2, 3, 4 faces, so it's not that one. We just talked about the sphere. The sphere has got 1 face, so it's not that one. And our triangular prism has 1, 2, 3, 4, 5 faces. So it could be this one. So now I need to choose another characteristic to work out whether it is the square-based pyramid or the triangular prism. So let's have a look at the vertices. So how many vertices? Well, I've got the prism in my hand. Let's do the prism. So this has got 1, 2, 3, 4, 5, 6. So I know it's not my triangular prism. Let's double check our square-based pyramid. 1, 2, 3, 4, 5. So it is our square-based pyramid. Well done if you worked that out. Okay, what we're going to do now is have a look at some reasoning, and then I'll explain to you what your activity is for the day. So tick the odd one out and explain why. So what you need to do is you need to have a think about the properties that we have learned about, okay? So I know that the sphere only has 1 face, but both of these shapes, the cube and the cuboid, have the same number of faces, edges, and vertices. So I might say, I know that the sphere is the odd one out because it is the only one that has a curved face, or it is the only one that doesn't have 6 faces, or it's the only one that doesn't have 12 edges, or it's the only one that doesn't have 8 vertices. Can you have a go at looking at these shapes and working out which one you think is the odd one out and why? Okay, well done if you've had a go at that. So I would say that the cylinder is the odd one out because it is the only one that does not have these triangular faces. Okay, so let's have a look at some reasoning then. Rob says all 3D shapes have 3 vertices. Is he right? Well, we already know that this shape doesn't have any vertices, and neither does this one. And some shapes have less than, and some shapes have more than. So we would say that Rob is wrong because spheres and cylinders have 0 vertices. Sally says all 3D shapes have 8 edges. Is she right? Well, once again, our sphere is a perfect example of how she is wrong because a sphere has 0 edges. Or I could have picked a different shape and said she is wrong because a triangular-based pyramid only has 6 edges. Okay, so your activity then, well done for listening. I know that was a long one. Circle sheet, you're matching the picture of the shape to the name of the 3D shape. Once again, you can pause the video here, or you could download the sheet on the Byron Wood School website. The semicircle sheet is time for you to write your name of the shape here. So the name of what each of these shapes are called, and then the number of edges that each shape has, the number of vertices that each shape has, and the number of faces. I would like every single person in the class to please complete this one, whether you start here or whether you end here. The triangle sheet is the riddle game. So I have 6 equal faces, 8 vertices, and 12 edges. What am I? So you need to work out based on the properties. You might want to use this sheet to help you with that one. So when you do this one will become much easier. And then you've got to tick the odd one out. So you might say the cone is the odd one out because it is the only one that doesn't have 6 faces, for example. And then we've got these reasoning ones. So Jack says all 3D shapes have vertices. Do you agree? So you've got to say whether he's right or whether he's wrong and give your reasons based on the properties of other 3D shapes. Well done, everyone. I know that was a super long lesson, but you all did a really amazing job. A few more days to the half term. Keep going, and we'll see you soon for another one. Bye, everyone.